Welcome to this video. In this video, we're going to be talking about free response question number 1 for the AP Calculus AB 2024 test. So this one talks about coffee. It says, the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius. For t is between 0 and 12 inclusive, selected values of c of t are given in the table. So that's this one up here, table shown. Problem A says, approximate c prime of 5 using the average rate of change of c over the interval t is between 3 and 7 inclusive. Show the work that leads to your answer, include units of measure. Okay, so when we're talking about the average rate of change, what is that we're trying to find? Let me sort of draw you a little picture to help you understand what we're looking for here. So let's assume we have some sort of T1 and some sort of T2, and let's, just for the sake of understanding what average rate of change is, we can go ahead and plot some points. Maybe T1 is here, maybe T2 is here, and maybe it follows some sort of curve like this. This is all just for the sake of illustration, okay? This is not relative to our current values. And then we assume that, C of T1 is going to be here, and like C of T2 is going to be here. So when we're talking about the average rate of change, what we're trying to find is we're trying to find the slope between those 2 points, okay? And how are we going to do that? Well, we can take the equation that we use for average rate of change, and that is going to be C of T2 minus C of T1 over T2 minus T1. Okay, and so for this specific problem, we have these two values, 3 and 7. So we're going to say that 3 is T1 and 7 is T2. So we're going to get, if we plug these into our average rate of change equation, we're going to see that we end up with C of T2 is 7 minus C of T1 is 3 over T2 minus T1, so 7 minus 3. We can go ahead and use the values in our table up above to plug in for C of 7 and C of 3. So we're going to go ahead and find where T equals 3 and where T equals 7 is in our table. So it looks like C of 7 is going to be 69. So 69 minus C of 3 is 85. Over 7 minus 3, so we're going to get 69 minus 85 is negative 16, all over 4 is going to be negative 4. So that is going to be our average rate of change of C over the interval from 3 to 7 inclusive. Don't just walk away from this problem though, right? So we need to include the units of measure. So what are your units of measure going to be? The way that I like to do this, especially if you have a numerator and a denominator, is you notice that each of those is going to have their own unit of measure. Okay, so up top we have C of t. We're dealing with C of t, and C of t is in degrees Celsius. So up top we have degrees Celsius. Down at the bottom we're dealing with t's, and t is determined in minutes. So we have minutes down at the bottom. So when we're taking the unit up at the top, the numerator, degrees Celsius, and dividing it by minute, go ahead and write this is going to be minus 4 degrees Celsius per minute. Okay, and that is our final answer for part A. Make sure you have the units. You're going to lose a point if you don't have them. You just leave it at minus 4. All right, let's move on to the next problem. So this one says to use a left Riemann sum with the 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 12 of c of t dt. Then we want to interpret the meaning of 1 over 12 times that integral in the context of the problem. All right, so we basically have 2 steps to this problem. The first one is a left Riemann sum. When you see the phrase Riemann sum, I want you to immediately think rectangles. We're going to be making rectangles. A Riemann sum, you're basically adding up the sum of several rectangles in order to try to approximate the area under the curve. So if we wanted to graph out C of t and t using the points in that data table, just as like a visual aid of what we're trying to do in this problem, let's say we go up by 3. Let's say this goes up by 20. And let's go ahead and plot all the points in this graph. So at t equals 0, our C of t is 100. So let's go ahead and plot that point there. At t equals 3, C of t is 85, so that'll be here maybe. At 7, it is 69, so that's like here maybe. And then at 12, it's at 55. So these are our points. I'm going to go ahead and connect them. This might not be what the curve looks like. Once again, this is just for the purpose of demonstrating, providing a visual aid for the Riemann sum. So as I said, Riemann sums, we're going to be creating these rectangles under the curve. So there's two different types. There's a left Riemann sum and a right Riemann sum. So take a look at this diagram, sort of understand what the difference between the two are. So you'll notice that with the left Riemann sum, what we're going to be doing, what's going to be happening is that the top left corner of each rectangle is going to be touching the curve. So that's what we're going to want to do with our points here. Our first rectangle is going to look like this. Our second rectangle is going to look like this. And our third rectangle is going to look like this. So you can see for each of these rectangles, the top left corner is touching the curve. Okay? This is different than if we had a right Riemann sum, right? I can show that to you now, just to see a comparison of the two, where the top right corner is touching the curve. So you can see the right Riemann sum is kind of an under approximation, the left Riemann sum is an over approximation, and that's specific to this curve. It might be different for other types of curve. Let's go ahead and add up these three rectangles to approximate the value of the integral from 0 to 12 of ct dt. So since it's an approximation, it's not going to be the exact value of the area under the curve. We're going to use this approximation sign. Let's go back to geometry. What is the area of a rectangle? This is one of the easier ones. It's just base times height. So for each of these rectangles, we need to figure out its base and its height, and then add up all the rectangles. So for this first one, the rectangle goes from the point t equals 0 to t3. So 3 minus 0 equals 3. So the base of our first rectangle is 3. Now we need to find the height, so we can multiply 3 by that. So the height of our rectangle is going to be C of 0. C of 0. And what is that equal to? That is equal to 100. So we're going to be multiplying 3 by 100 to get the area of this first rectangle. Okay, let's move on to the next rectangle. This next rectangle, let's check out what its base should be. So we're going from t equals 7 to t equals 3. So 7 minus 3 is equal to 4. So the base of that second rectangle is 4. What is our height going to be? Well, our height is going to be whatever this point is here, and that is C of 3. What is C of 3 in the table? It's 85. So this is going to be the area of this second rectangle here. Okay? Moving on to the third and last rectangle. What is the base going to be? We are going from 7 to 12, so 12 minus 7 is equal to 5. So the base of that third rectangle is 5. What is our height going to be? Well, what is this point? This point is C of 7. C of 7 is 69. So the height of that third rectangle is 69. So this will give us the area of this rectangle here. And now we are going to add these all up. What value are we going to get? We are going to get that this is 985. So this is part 1 of the answer. That's the value, but that's the approximation of the value of the integral from 0 to 12 C of t dt using that left Riemann sum. Now we need to do part B of this problem, which is interpret the meaning of 1/12 times this approximation in the context of that problem. So what is the sum? The sum is the area under the curve. It's a total temperature that this coffee has changed from t equals 0 to t equals 12. So if we take this total temperature and we divide it by 12, that range, t equals 0 to t equals 12, 1/12 times the integral of from 0 to 12 of C of t dt is the average temperature of the coffee in degrees Celsius from t equals 0 to t equals 12. And that should be the answer to part 2 of this problem. Okay, we're having so much fun. Let's keep the fun going. On to problem C. So this one says for t is between 12 and 20 inclusive, the rate of change of the temperature of the coffee is modeled by C prime. And it's given with this equation, where C prime is measured in degrees Celsius per minute. We want to find the temperature of the coffee at time t equals 20 and also show the setup for our calculations. So it's good for us to understand what it is exactly that we're trying to find. So the temperature of the coffee, would we be using C prime of t or C of t there? We would be using C of t. That's correct. Why would we be using C of t? Well, remember in our initial problem statement, it said the temperature of the coffee in the cup at time t equals t minutes is modeled by this function C. We do not want to solve for C prime of 20 because that will give us the rate of change at t equals 20 minutes time. What we're solving for is C20. What is C20? How do we solve for it? Okay, so let's think about it. We have this rate of change equation. Maybe we can somehow figure out, we can work backwards and figure out C20 using that. And that would be the exact correct logic. So one of the fundamental theorems of calculus is that if you take the integral of some function from a to b, this is going to equal the integral of that function, so big F of x in this example, big F of b minus big F of a. We can use this equation with C prime of t to solve for C of 20. Let me show you how. Okay, so let's move this out of the way. Let's go ahead and set up an equation like that. So for this specific problem, we're looking between 12 and 20. So let's set that up as the limits of our integral. So from 12 to 20, C prime of t dt is going to be the same thing as C of 20 minus C of 12. You see how I went from this equation to applying it to our actual problem here? That's pretty good for us because check out what's in that equation, C of 20, which is what we want to solve for in this problem. So we want to isolate C of 20 on its own. So what we can do is we can add C of 12 to the other side to just isolate C of 20. So we're going to get that. So if we add C of 20 to both sides, we're going to get that C of 12 plus the integral from 12 to 20 of C prime of t dt is equal to C of 20. That's awesome. That's what we were trying to solve for. So you might also notice, okay, so C of 20, that looks kind of familiar to us. That is in our table. Woo! So we can go ahead and substitute 55 for C of 20. So 55 plus the integral from 12 to 20. We can also substitute in our C prime of t because we have it. It was provided for us in the problem. Let me clean this up a little bit. 12 to 20. What is this equation? Minus 24.5 e to the 0.01 t all over t dt is equal to C of 20. So this is a calculator problem. So go ahead and use your calculator to figure out what this mess is. You should get that it's equal to roughly negative 14.670812. And then we're going to be subtracting that from 55 to get what C of 20 is, which is 40.329. I'm just going to go ahead and round it at that point. Degrees Celsius. And that should be the answer for part C. All right, let's go ahead and move on to part D. This one says, for the model defined in part C, it can be shown that C double prime of t is equal to this equation. For t is between 12 and 20, not inclusive, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. Give a reason for your answer. We've got one more equation thrown into the mix. Now we have C double prime of t. And so if C prime of t was giving us the rate of change of the temperature of the coffee, what would C double prime of t give us? It should be giving us the rate of change of the rate of change of the temp of the coffee. So the second derivative will give us information on the rate of the change. So this means that the sign of the second derivative matters to us in this problem. So if we go ahead and we graph this, right, this is a graphing calculator problem, you'll see that it's strictly greater than 0 on that interval that we're looking at, which is between t equals 12 and between t equals 20. So because it's greater than 0 on that interval, the entire interval, we can assume, let's go ahead and write this down, because c double prime of t is greater than 0 on the interval 12 is less than t is less than 20, the rate of change of the coffee is increasing. And that should be it for our answer, right? So hopefully this helps you out with these problems. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.